time for presentation is 3 minutes. So make sure you take note of the time ya. Alright. Okay. So Emma boleh mula? Saya mute saya punya screen ya. Mute saya punya screen pula.
Teacher, one of our teammates is not here yet.
Oh, ya ke? Siapa?
Aisyah.
Tapi dia nak join nanti ke? Like,
Dia punya part belakang-belakang ke?
no.
Your part first kali.
Okay, kita tunggu dalam 1 minit.
Teacher, apa jadi kalau kita orang exceed 3 minutes?
Tak apalah, dia lebih kepada untuk saya consider je lah aspek time management itu je lah. Ini Aisyah dah masuk dah.
Okay.
Sorry. I thought 10:50. Sorry.
Saya faham. Saya yang bersalah. Saya yang bersalah. Tak
Okay,
apa,
okay.
okay.
Sorry. Okay, I'll start now. Okay.
Boleh bernafas ke tu?
Tak boleh sangat tapi tak apa.
Okay, kita mula.
Okay, teacher sekejap. Saya nak ambil nota.
Teacher.
Okay, I start now ya teacher. Bismillahirrahmanirrahim. Okay, Assalamualaikum and good morning to all my fellow friends and teacher Nadra. So today me and my group will be presenting about space weather. Okay, so what is space weather? Space weather is essentially emissions from the sun radiation. Sorry, teacher. Okay, space weather is essentially emissions from the sun radiation, magnetic field that erupts from the solar surface, pumps out into space, sometimes right toward the Earth. So when it impacts the Earth, it impacts the technology. That's what we call space weather.
So in this slide, I will be talking about the formation of auroras. If you live in higher latitudes, the northern lights, also known as the aurora borealis, are the stunning swirls of light dazzle the night skies of the upper northern hemisphere. In the southern hemisphere, they're called the aurora australis, or the southern lights. Auroras occur due to the interaction between Earth's atmosphere and solar flare hurling charged particles at us from the sun. The sun constantly shoots plasma such as electrons, protons, and alpha particles out into space at a great speed. We call this as solar wind. When it meets the magnetosphere, it protects us from these harmful particles. Although most of the solar wind is blocked by the magnetosphere, some particles become briefly trapped in a ring-shaped holding areas around the planet. What causes these lights to appear, you may ask? When Earth is in the path of the particle stream, our planet's magnetic field and atmosphere reacts. When charged particles come in contact with oxygen and nitrogen, they transfer energy, causing them to light up the stunning display of colorful blue, red, yellow, green, and orange lights that shifts gently and change shape like softly blowing curtains. This next slide will be showing you a 20-second video of aurora lights. Sit back and enjoy one of the best spectacles of the night sky.
Disturbances to telecommunication. Solar flares have been known to affect electronical energy communication because their energy stirs up the Earth's upper atmosphere, making radio broadcasts noisy and weak. X-rays and UV radiation emitted by solar flares can affect Earth's ionosphere and disrupt long-range radio communication. The meaning of ionosphere is a layer of Earth's atmosphere which contains a high concentration of ions and free electrons and can reflect radio waves. The coronal mass ejection, which stands for CME, is caused by solar storms and it contains charged particles. If Earth happens to be in the path of CME, The charged particles can slam into our atmosphere, which can disrupt telecommunications, and mobile phone services will fail.
Now moving on to effects on navigation system. Communication from the ground to satellites is affected by space weather as a result of perturbations of the ionosphere, which can reflect, retract, or absorb radiation.
Nami ada connection issues ke? Oh, okay. Boleh kawan tolong sambungkan?
Okay. So this includes radio signals from Global Positioning System, that is GPS satellites. So space weather can change the density structure of the ionosphere by creating areas of enhanced density. And this modification of ionosphere makes GPS less accurate and can even lead to a complete loss of the signal, because the ionosphere can act as lens or a mirror to the radio waves traveling through it. So we've prepared some questions for you guys. There are 3 objective questions and 2 true and false questions. So the first question is, what normally protects us from space weather? So anyone who wants to answer this?
Feel free to open your mic and try to answer.
Emma, can I answer?
Okay, Aina, go.
B, Earth's magnetic field.
Yes, that's true. So the second question is, which one of these is false about aurora? Okay. Anybody? Guys? Boys, girls?
Can I answer?
Nice. Okay.
C. Aurora shimmers in the ground and is visible at day.
Yep. Because aurora shimmers in the sky and not ground and is visible at night. Okay, so the third question is, which of the following can affect Earth's ionosphere? Okay.
Can I answer?
Yes.
The answer is C, navigation system.
No. The answer is X-rays.
Oh, okay, sorry.
It's okay. Jadi macam Melissa cakap, X-rays dengan UV radiation can affect Earth's ionosphere. So, okay, now it's true or false. Question 1. As the solar wind hits the Earth's atmosphere, it will release energy. This is what causes the northern lights, that is aurora. So, is it true or false? Lagi lah pula. Okay. No. Dah lah. Abdullah. Okay, tak ada. Rizky?
Guys, please answer. It's okay if you guys get it wrong. We can
We can learn.
We don't have much time.
Yes. Cepat lah.
True.
Yes. That's true. So question 2 is the result of perturbation of the ionosphere can reflect, and absorb radio waves. True or false? guys.
Emma boleh tolong summarize sebab dah extra 5 minit. Terus summarize, kita skip question
Summarize?
Terus nak tutup sebab dah extra 5 minutes.
Okay, that is true. But okay, that is all from us.
Thank you,
Thank
teacher.
you. Thank you, teacher.
Sorry,
So
guys.
sorry,
teacher. Korang
Teacher,
korang
my
punya-
wifi.
Sorry, teacher.
Sorry lah,
It's okay, it's
teacher.
okay. Tak apa.
Korang chaotic sikit.
Tak apa, technical issues tu tak apa. Okay, so first of all, thank you so much for your efforts. Memang very simple layout, simple combination of colours, tapi ideal lah, senang nak baca lah, good contrast ya. And then nanti saya akan bagi further comments. Cuma bagus jugalah kamu minta student unmute microphone lepas tu tanya ya. Lepas tu sebut nama pula tu. Macam cikgu betul pula. Okay, thank you. Good technique. Okay, so next group, group Saif. Can you share your screen, Saif? Saif ada kan? Ada. Ada. Alright. You can share your screen ya.
Okay. Okay, boleh start saja. Okay. Assalamualaikum and good morning to Teacher Nadra and my fellow classmate. My name is Iman. Today I will be presenting about space weather and its effect on Earth with Saif Sirhan, Rizky Alhaj, Ziad Haris and Danish Karizmi. Next page. Okay, so what is space weather? Space weather is a condition in space caused by the sun that can affect satellite and technology on Earth as well as human life and health. As modern civilization has become more dependent on continent-sized electric power distribution grids, global satellite communication, and navigation system, and military and civilian satellite imaging, it has become more susceptible to effects of space weather. Next slide, we'll be talking about effects of space weather to Earth. They discourage me.
Sorry. So the first effect of space weather to Earth is, the first effect is solar flares can produce strong X-rays that degrade or block high frequency radio waves used for radio communication during events known as radio blackout storms. The second effect is coronal mass ejection, or CMES, can cause geomagnetic storms at Earth and induce extra currents in the ground that can degrade power grid operation. So the third effect is the greatest potential damage caused by space weather in economic terms would be the destruction of infrastructure required for
Danish ada connection problem kot. Boleh ada siapa-siapa sambung?
The greatest potential damage caused by space weather in economic terms will be the disruption of infrastructure required for continuing size power distribution system. Geomagnetic storm can also modify the signal from radio navigation system, or known as GPS and GNSS, causing degraded accuracy and also can produce the aurora. Astronauts, as well as passengers and crew flying polar routes, are vulnerable to higher than normal level of radiation.
That's all from us, and thank you for listening. Sorry sikit je teacher sebab buat last minute.
Tak apa, just nice. You only exceeded 30 seconds saja. Very good. Alright. So tak apa, nanti saya komen kemudian ya. Saya summarize dulu. Okay, next group ialah group Abdullah. Can you share your screen?
Yes, yeah.
Alright.
Gotcha. Okay, so can we start now, teacher? Okay, all right.
Right.
Assalamualaikum and a very good morning to my fellow teacher and friends. Today, my friends and I will be presenting on the subject space weather. So what is space weather? Next slide, please. Well, according to the science textbook, space weather is defined as the phenomena that occur on the surface of the sun and in space. According to Wikipedia, on the other hand, space weather is a branch of space physics and a concerned with the time-varying conditions within the solar system, including the solar wind, emphasizing the space surrounding the Earth, including conditions in the magnetosphere, ionosphere, thermosphere, and exosphere. Space weather is distinct from, but conceptually related to the terrestrial weather of the atmosphere of the Earth. The term space weather in the 1950s and came into common usage in the 1990s. Next slide, please. Phenomena that occur on the surface of the sun are such as coronal mass ejections, prominences, solar flares, and sunspots. Phenomena that occur in space are solar winds, solar radiation storms, and geomagnetic storms. Now I will pass the presentation to my beloved friend Mukis Husaini.
Thank you, Taufik. This slide shows coronal mass ejection. Next. This is an example of prominences. Next. This is an example of solar flare. Next. This is an example of sunspot. Next. And this is an example of solar wind. Next. This is an example of solar radiation storm. Next. And the last one is geomagnetic storm. Now I'll pass to Abdullah.
Well, thank you very much, Mukris. I hope everyone is enjoying our presentation so far. Now we are going to talk about the effects of space weather on Earth. Before I continue, I would like to apologize if my fellow group members and I mispronounce some of the words that will be shown from this slide onwards. Number 1. Solar flares impact Earth only when they occur on the side of the sun facing the Earth. It is because flares are made of photons. They travel out directly from the flare side. So if we can see the flare, we can be impacted by it. Solar flares strongly influence the local space weather in the vicinity of the Earth. They can produce streams of highly energetic particles in the solar wind or stellar wind, known as a solar particle event. These particles can impact the Earth's magnetosphere and present radiation hazards to spacecraft and astronauts. The second effect is coronal mass ejections, also called CMEs. They are large clouds of plasma and magnetic field that erupt from the sun. These clouds can erupt in any direction and then continue on in that direction, blowing right through the solar wind. Only when the cloud is aimed at the Earth will the CME hit Earth and therefore cause impacts. Thus, it causes a temporary disturbance of the Earth's magnetic field. Number 3, high-speed solar wind streams come from areas on the sun known as coronal holes. They are basically continuous flows of charged particles. These holes can form anywhere on the sun, and usually only when they are closer to the solar equator do the winds they produce impact Earth. These solar winds disrupt communications, navigation systems, and satellites. Last but not least, communication from the ground to satellite is affected by the space weather as a result of perturbations of the ionosphere, which can reflect, refract, or absorb radio waves. This includes radio signals from the Global Positioning System, GPS satellites. Therefore, space weather causes degradation of radio communication. Next, I introduce Omar Rashidan to continue this presentation.
Thank you, Abdullah. The aurora borealis, or the northern lights, and the aurora australis, southern lights, are the result of electrons colliding with the upper reaches of the Earth's atmosphere. Protons cause faint and diffuse aurora, usually not easily visible to the human eye. The electrons are energized through acceleration processes in the downwind tail or the night side of the magnetosphere and at lower altitudes along auroral field lines. The accelerated electrons follow the magnetic field of Earth down to the polar regions where they collide with oxygen and nitrogen atoms and molecules in the Earth's upper atmosphere. In these collisions, the electrons transfer the energy to the atmosphere, thus exciting the atoms and molecules to higher energy states. When they relax back down to the lower energy states, they release their energy in the form of light. This is similar to how a neon light works. The aurora typically forms around 80 to 500 kilometers above the Earth's surface. Next, please. Number 6, space weather disturbances cause geomagnetic field variations that induce electric currents into power transmission systems on the ground. These geomagnetically induced currents, or GIC, follow to ground through the windings of power transformers where they produce extra magnetic flux that can saturate the transformer core. And lastly, geomagnetic storms can potentially cause disruption of electrical systems. It has been suggested that the geomagnetic storms on the scale of the solar system of 1859 today would cause billions or even trillions of dollars of damage to satellites, power grids, and radio communications, and could cause electrical blackouts on a massive scale that might not be repaired for weeks, months, or even years. Such sudden electrical blackouts may threaten the food production that may affect a country massively. I will now pass this presentation to my friend Noah Imran.
Thank you, Umar. Now that you all have listened and I'm sure paid attention to the presentation, we will answer some short quiz questions that is made by us. For the first question, when was the term space weather first used? For this one, can I get Saif to answer? If Saif can't answer this question, may I get Rizky? Oh, Rizky has left the meeting actually. That's all right. Adriana, can I get you to answer, Adriana, please? What about someone else? Okay.
Okay, anyone can
Mas.
try.
Yeah. Anyone.
Need to try. Everyone
Yeah.
can try.
Me?
Yeah, sure. You can answer.
Sorry, no, I tak tahu.
Okay, it's okay. I'm just gonna tell the answer. The answer is the term space weather was first used in the 1950s, like what it was said in slide 2. Moving on, phenomena that occurs on the surface of the sun. Give out 2 phenomena that occur on the surface of the sun and in space. May I get Iman to answer? Iman, can you answer this question?
Yeah, sure. Is it sunspot and solar flash?
Yes, that's correct for the surface of the sun. What about phenomena that occur in space?
Is it solar wind?
One more.
And don't know.
Okay, it's okay. The answer is either geomagnetic storm or solar radiation. Okay, thank you, Iman, for answering my question. The next one is, Which space weather phenomena causes disturbances of the Earth's magnetic field temporarily? Zia, is Zia here? Zia is not here.
Anybody who would like to
Yeah,
answer?
anybody? If anybody wants to.
Feel free.
Sorry if the noises in the background.
Okay, no one nak jawab.
Okay, sure.
The answer is coronal mass injection.
Yes, you are correct. Thank you, Mas. For the fourth question, what are the result of electrons colliding with the upper reaches of Earth's atmosphere? Does anybody want to answer?
Can I answer?
Yeah, sure.
The answer is it will cause the northern lights, the aurora.
Yes, correct. Now, the final question. Give out 3 things that geomagnetic storms could damage. Does anybody want to answer, or should I call out a name?
Can I answer?
Sure, Aisha.
Satellites, radio communications, and power grids.
Yes, you are correct. Okay. That's all for the questions. Thank you to everyone for listening to my group's presentation. I hope you all enjoyed what we presented to you all, and especially the short quiz. We are also sorry if we sounded like we were rushing because of the time limit. We just realized it this morning. Thank you so much.
Thank you, Chair. And thank you to
Okay.
the classmates.
Alright, thank you. Guru ni pun kena jaga time management ya. You exceeded 5 minutes. Tapi tak apa, thank you so much for your presentation. Okay, nanti I will give you a specific comment for each group. So the next group I think is Intan's group. Can you share your screen, Intan? Sorry, saya
Okay, kejap aja ke?
Okay, silakan. Sorry ya, Group Abdullah tadi towards the end tu saya unmute saya punya mikrofon, saya baru perasan. Dengan timer saya bising kan. Sorry.
Teacher dah dapat? Okay. Hi and Assalamualaikum to Teacher Nadra and my fellow classmates. So today we are going to present about space weather, which is subtopic 9.2. So what is space weather? Space weather is a phenomena that occur either on the surface of the sun or in space. For example, phenomena on the surface of the sun is solar flares, prominences, sunspot, and coronal mass ejection. And in space is solar wind, solar radiation storm, and geomagnetic storm. So today we are going to talk about the effects of space weather towards Earth, and Damia and Alisa will explain about the effects to you guys.
Okay, firstly, I'll be explaining about auroras. An aurora is a display of colorful lights that can be seen in the dark night sky at areas near the South Pole and also South Pole. When the sun is active, it releases a lot of charged particles that are trapped by Earth's magnetic field. These charged particles are then brought by Earth's magnetic field to the North Pole and also South Pole, where the charged particles collide and interact with nitrogen and also oxygen at the upper atmosphere. Okay, as you can see in the picture, this interaction produces green, blue, and also red colored lights known as auroras. An aurora produced at the northern hemisphere is called aurora borealis, whereas an aurora produced at the southern hemisphere is called aurora australis. Next, we'll move on to disruption in radio communication. During a geomagnetic storm, the flow of electrical charged particles from the sun enters the ionosphere near the magnetic poles of Earth and ionize molecules to form electron and positive ion. The increases in electron causes the ionosphere to absorb instead of reflect radio waves at areas near the poles of the Earth. For these reasons, radio signals near the poles of the Earth tend to be weak. This situation disrupts the radio communication of aircraft in the area. For example, airline companies uses forecasts of geomagnetic storms that plan their trips and avoid flying in areas where there is disruption in radio communication. A geomagnetic storm is a temporary disruption of the Earth magnetosphere that is caused by solar winds or strong eruptions of radiation. Ionosphere is the atmospheric layer that functions to reflect radio waves in communication.
So next is the disruption in navigation systems. Ionospheric disruption caused by the flow of electrically charged particles from the sun could reduce the accuracy of GPS navigation system that is used by ships, aircraft, and land vehicles. This is caused by electrons of varying densities in the ionosphere produced by geomagnetic storms. Space weather also affects the condition of satellites that are used not only in navigation systems, but also in media and telecommunications. Last but not least is disruption in power grid lines. A geomagnetic storm can cause unexpectedly high electrical currents to run through long conductors such as power lines. These situations can melt the transformer, damaging the power line system and causing an electrical power outage. That is all from us. Thank you for listening.
Okay, thank you so much, Team Damia, Alisa and Intan. Ada extra 40 seconds je. Good. Apa time management a bit better compared to other groups. Good job. Okay, so sekejap ya. Next I think it's Alia, Group Alia. So, silakan Group Alia.
Sekejap, wait, teacher.
Boleh. Nak saya sharekan ke? Sebab saya dah boleh buka.
Sekejap, teacher.
Okay.
Tengah
Boleh, no problem.
it's sharing, right? Is it sharing?
Yes, boleh nampak.
Good morning, classmates. Today, me and my group mate, Batrisha, Umaira, and Yasmin will be talking a little bit about the definition of space weather and its effect on Earth. So, what is space weather? Space weather is defined as solar surface phenomena such as solar flare, prominence, sunspot, and coronal mass ejection. It can also happen in space such as solar wind, solar radiation storms, and geomagnetic storms. And for your information, the term space weather was first used in the 1950s and came into common usage in the 1990s.
So the effects of space weather are radio transmissions can be disordered or completely blacked out. Next, it has the potential to disrupt the power grids that supply us with electricity. And solar storm radiation can also be dangerous to astronauts in space. So, there are satellites for research, telecommunications, navigation, and weather that could undergo tool failures and computer errors. And on Earth, it can generate ground electric currents, which can overload transformers and cause massive damage to electric grids.
How does the Earth protect us? The Earth's magnetic field shields us from space weather. The Earth's magnetic field can buckle during a powerful solar storm. This is most common when the storm is accompanied by a coronal mass ejection.
How do you forecast the space weather? Study shows that a thorough analysis is the starting point for a good space weather forecast. SWPC forecasters assess the current state of the solar geophysical environment by analyzing near real-time ground and space-based observations from the Sun to the Earth and points in between. Forecasters of space weather also examine the 27-day recurrent pattern of solar activity. Forecasters can predict space weather on timescales ranging from hours to weeks based on a thorough analysis of current conditions, comparison of these conditions to previous situations, and use of numerical models similar to weather models. This is a statement from Prof. von Fey Seibenbergen. He emphasizes that the consequences of space weather hazards can result in anything from a mild operational inconvenience to total loss of segments of our modern technological infrastructure.
Some facts: the Carrington event was a powerful geomagnetic storm on September 1859. A solar coronal mass ejection (CME) hit Earth's magnetosphere and induced the largest geomagnetic storm on record. The associated white flare in the solar photosphere was observed and recorded by British astronomers Richard Carrington and Richard Hodgson. This is why it is called the Carrington event during the year 1859. The storm created strong auroral displays and caused serious damage to the telegraph system. If a solar storm of this magnitude occurring today, it would surely cause widespread electrical disruptions, blackouts, and damage due to extended outage of the electrical grid. Aurora are usually only visible in the far north, could be seen in Central America, the Caribbean, and Hawaii. An aurora, also known as polar lights, aurora polaris, northern lights, aurora borealis, or southern light aurora, is a natural light displaced in the sky that is most commonly seen in high latitude regions around the Arctic and Antarctic. The auroras produce dynamic patterns of brilliant light that appears as curtain rays, spirals, or dynamic flickers that covers the entire sky. So the word aurora, it is actually derived from the name of the Roman goddess of the dawn, Aurora, who traveled from east to west, announcing the coming of the sun. Its ancient Greek poets used the name metaphorically to refer to dawn, often mentioning its play of colors across the otherwise dark sky. So, space weather describes the vibration or changes in space environment between the sun and Earth. When it reaches Earth, it energizes the magnetosphere and accelerates electrons and protons down the magnetic field lines, where they collide and with the atmosphere and ionosphere, especially at high latitudes. And that's all from us. Thank you. Thank you so
Okay,
much.
thank you Alia and team. Extra 2 minutes from that presentation, yeah. Okay. Next group, I would like to call upon siapa ni? Ifrah punya group pula. Dengan Ifrah dengan Narisa. After this Narisa, eh.
Okay. Sekejap teacher. Sekejap teacher. Sekejap.
Boleh.
Boleh nampak ke?
Boleh.
Okay.
Ya, boleh.
Okay.
Hi and good morning to all my fellow friends and teacher Nadra. Today we're going to present about space weather and its effect on Earth. My crewmates include Ifra, Catherine, and Melina.
So, what is space weather? Space weather is the condition in space caused by the sun that can affect satellites and technology on Earth as well as human life and health. The picture shown is an example of the condition of space weather. You can see solar flares, coronal holes, sunspots, coronal mass ejections, and many more. Next, what are the effects of space weather on Earth? Our planet's magnetosphere keeps most of space weather's effects where they belong safely up in space. Some radiation does, however, reach orbiting satellites and astronauts, people in aircraft, and sometimes even the ground.
So next is the formation of aurora. So firstly, what is an aurora? It is actually a natural light display that shimmers in the sky. And it also comes with certain colors such as colorful blue, red, yellow, green, and orange that light shift gently and change shape like softly blowing curtains. However, auroras are able to be seen at night and usually only appears in lower polar regions. So how do they form? The sun is a super hot gases made up of electrically charged particles, which are protons and electrons. These particles are then emitted from the sun to go into the Earth's light with atoms and molecules in our atmosphere. The collision causes a colorful glowing halo around the poles where auroras form. As you can see, this picture right here shows how it's happened.
So next is about the disturbance of telecommunication. So how does the space weather disturb our telecommunication system? The main cause is actually geomagnetic storms. So these geomagnetic storms that comes from the coronal mass ejections will actually disrupt satellite operations because the electrical appliances in satellites are very sensitive towards the energy particles ejected by the sun. Next, it will also change the Earth's atmosphere. So what will happen? As we know nowadays, our telecommunication system really relies on the satellites to receive signals and then transmit it back where it needs to be. So when our satellites malfunction, our telecommunication system will not work too. So some of the things that might happen is it will interrupt satellite TVs, internet and cell phone services, and also interfere with the global positioning system. This can be very dangerous since if you're like lost somewhere, you don't have GPS, and if you're like in an emergency situation, you can't really like call someone for help. So now it's time to test your understanding. I now will post a link at the chat section. The quiz, you guys can do it anytime. Do not waste any time. I'll just post the leaderboard later in the group. Okay. So that's it from us. Thank you.
Okay, you're welcome. So okay, timing just nice. Lebih dalam 20 seconds macam tu saja. Thank you so much. Oh, okay. So wah ni bila-bila masa diorang boleh buat kan?
Yes, boleh bila-bila je.
Right, nanti post dekat group Telegram sekali ya. Alright, last one, Narisa. Last but not least.
Okay, hold on. Yeah. Ajana, checking in. 1 2 1 2.
Okay. Is the microphone okay?
Yes.
Thank you.
Okay. Can everyone see that?
Yes.
Okay, good. Hi, we're the last group representing about effects of space weather activity 9.3 on page 264. So, the textbook definition given on the previous page, 263, is a phenomena that occurs on the surface of the sun, such as solar flares, prominences, sunspots, and coronal mass ejections, and in space, such as solar wind, solar radiation, storm, and geomagnetic storm. I'm sure there's a bunch of other definitions that are a lot more in-depth, like in Wikipedia or something, but it's a lot easier to understand from the textbook. I'd
Okay, I'm sorry. Effects on Earth. Formation of aurora. Auroras are formed because some of the ions from solar wind become briefly trapped in the Earth's ionosphere. I'm sorry. Which are centered around the Earth's geomagnetic poles. The ions then collide with atoms of oxygen and nitrogen, which causes an aurora.
The next effect is degradation of HF radio transmissions, HF meaning high frequency. HF radio utilizes a portion of the ionosphere. Ionospheric and geomagnetic disturbances caused by solar flares and coronal mass ejections reduces usable HF frequencies, causes signal fading, and in some cases, HF fade-outs.
Disturbed navigation systems. Communication from the ground to satellites is affected by space weather as a result of perturbations of the ionosphere, which can refract, or absorb radio waves. This includes radio signals from Global Positioning System (GPS) satellites. This disrupts makes GPS less accurate and can lead to a complete loss of the signal.
The next is disrupting power lines. Space weather can produce electromagnetic fields that induce extreme currents in wires, disrupting power lines, and even causing widespread blackouts.
Okay, increased pipeline corrosion. Pipelines are often made of conducting material like steel. Intense electric currents flow in the atmosphere at high latitudes during space weather disturbances. These create fluctuating magnetic fields, which, by the process of electromagnetic induction, induce currents in the Earth's surface. The currents find path of least resistance and become concentrated in pipelines, causing pipeline corrosion. Next.
So these are the questions. If you want to answer, just say it, I guess. You can type it out in chat if you want. So the first question is, how does space weather phenomena occur? Anyone at all? No? Really?
Call someone.
No. Can you call someone? Pick someone.
I pick randomly, okay? Aina, can you answer? If can't, you can just say in the chat. Oh God.
Is it A?
Yes, it is A. Thank you.
Congratulations. Okay, question number 2. How do auroras form? This is
absolutely
easy. Oh my God.
No? All right, I'm calling a name. I don't know. Melina? Hello?
B.
That is correct. Last question. What are pipelines usually made of? I'd call someone.
This is so okay. Abdul or Catherine or anybody, please. This is easy.
Can I answer?
Yeah.
Okay.
Is it C?
Yes, it is C. That's all. Thank you.
Yay. Oh God, this is so awkward.
All right, thank you so much, Narisa and friends. Okay, so Alhamdulillah, we have completed all of the presentations. Okay, saya share overall comment dulu. So perhaps most of you are using Canva. So Canva is a good place where we can find templates that are easy for the eyes. Most of your presentations memang easy for the eyes, good color combination and also good fonts are used, so very clear, saya boleh baca lah. Lepas tu secara overall juga I can see that most of you provide different content, different explanation regarding effects of the space weather. It shows that you are doing research, kamu actually buat research mengenai perkara ni, so that is good lah. Okay, going through from group by group ya. Okay, untuk group Emma tadi, as I mentioned before, good combination of layout and font, and also I like that you highlighted important points of your presentation by underlining different concepts lah. But I would think that for a 3-minute presentation, your presentations are a bit wordy, ada banyak teks ya. So maybe you can improve upon that later. Kemudian untuk group Iman, Saif and the gang, I think the way you introduce space weather awal-awal tu very brief tapi very concise, good, very good. And then it would be better for your group to support your explanations using related diagram or related picture lah. Okay, tadi tu in terms of time management quite good ya, 30 seconds saja lebih, tapi mungkin sebab kamu tak include quiz untuk kawan-kawan ya. Okay, and then untuk group Abdullah, okay, overall apa nak kata, a bit wordy, banyak sangat teks, so jadi saya macam struggle jugalah nak baca tadi. Tapi satu lagi masalahnya bila wordy ialah we have to understand that some of our audience might be accessing your presentation using smaller devices. So bila tu wordy, your font will be smaller, jadi dia jadi susah nak baca lah. So ideally kita punya, ini kalau PowerPoint slide ya, kalau Canva punya slide saya tak sure. Ideally untuk PowerPoint punya slide, untuk presentation purposes, font paling kecil ialah size 16, 18 macam tu. Kalau smaller than that memang struggle jugalah. Itu pun saya kena ambil maklum untuk diri saya sendiri juga ya, kadang-kadang pun saya pun terlupa. And then for group 4, untuk group Damia, Alisa dan Intan, good time management and I like that you are using different color to highlight important points of your text. Okay, and you have also provided good pictures to support your argument atau support your explanation. And then untuk group Alia, I like that you use short text for your explanation, and you are using good many pictures to help your explanation. And I also like that starting daripada group Abdullah, group Alia, kejap ya, ada satu group lagi. I think these two groups adalah antara group yang you have stated where you get your information. You stated where your reference lah, which is good. Okay, bagi tahu reference kat mana kan. Okay, untuk group 6 pula, interesting that you are using PowerPoint and your team is also interesting. So I can see that since you are using a unique team, it causes you to try to minimize the content of your presentation, which is good. Maknanya kamu kamu bagi ayat pendek-pendek dan ada supporting picture, which is good. And then finally untuk group 7 pun sama, you provided good pictures to support your explanation, and mungkin sebab kamu group last, so macam bersemangat kot, so bersemangat tu infectious jugalah, which is good. So overall some of the improvement that I would like to suggest to all group, please include your references. Maknanya setiap statement tu kamu refer kat mana. Sama ada kamu nyatakan katalah pasal effects on GPS tu, kamu refer pada website mana. So tulis kat bawah lah, taken from atau reference dia daripada ditulis oleh siapa, website dia siapa ya. Sebab apabila kita membuat pembentangan yang bersifat akademik macam ni, we have to always cite our sources. Sebab apa yang kamu explain tu bukanlah datang dari kamu punya pemikiran logik semata-mata kan, but it comes from your research. So we have to cite siapa yang kita refer. overall, most of your presentation memang kalau convert jadi website, memang cantik lah. Memang orang boleh access dan boleh belajar pasal effects of space weather ya. Good job everyone. So, later I will review your presentation one more time and then I will give overall TP lah, dapat TP berapa. Tapi most of you TP 3, TP 4 tu memang dalam tangan dah lah. Alright, so that is all for today. I will provide the link for today's attendance after this ya. Saya ingat nak letak kat sini tapi tak sempat. So, satu lagi. When you want to ask questions, tanya secara overall dulu ya. Kata, okay, this is the question. Okay, siapa nak jawab? Jangan macam this is the question terus pick nama ya. Tak boleh ya. Kita bagi peluang untuk audience digest the question first and then baru kita answer. And then saya rasa towards the end tadi bila ada idea kata boleh respond dengan tulis dalam in-com messages. That is a good idea lah. Instead of tunggu orang unmute microphone, kita boleh minta kawan-kawan kita jawab dekat chat box saja. So okay, thank you so much for all of your presentation. Good job everyone. I am really impressed with the level of your understanding. Thank you so much for coming today. Thank you for your responses. Sekian, wabillahi taufiq wa hidayah. Assalamualaikum. See you next week.
Thank you, teacher, for your
Thank you, teacher.
Thank you, teacher.
Thank you, teacher.
Sampai tak bernafas dah. Alright. See you.
Thank you, Chair.
You're welcome.
Thank you, teacher.
Teacher,
Ya.
nak cakap je, actually Chair,